welcome to another video. Let's show that this expression is equals to 1 if inverse cos of alpha plus inverse cos of beta plus inverse cos of gamma is equals to 1 pi. And let's not forget that 1 pi is equals to 180 degrees. So now let me write this equation. Now we have inverse cos of alpha plus inverse cos of beta plus inverse cos of gamma equals to 1 pi. So what to do now is to write one of these in terms of, that is to express this or this in terms of order. So now let me express inverse cos of alpha in terms of inverse cos of beta and inverse cos of gamma. And that will be inverse cos of alpha is equals to pi minus inverse cos of beta minus inverse cos of gamma. So this is just like making this the subject of the formula. Now to get rid of this inverse cos, then I can now take the cosine of both sides. Okay, now take the cosine, okay, of both sides. Take the cosine of both sides. So this will be inverse cos of alpha equals to cos, open square bracket, pi minus inverse cos of beta minus inverse cos of gamma. Now, in this case, inverse cos multiplied by cos, that will be 1. So this will reduce to alpha equals to cos square bracket. This will be pi minus, I can write this to be, now the minus sign, I can make the minus sign precede the what? The precede the parentheses, so that within the parentheses will be inverse cos of beta plus inverse cos of gamma. Okay, so that we can have cos square bracket pi minus parentheses inverse cos of beta plus inverse cos of gamma. All right, now this angle will be in the second quadrant, and we know for sure that when we consider this, when we talk about the second quadrant, now cosine will take negative. That is the cosine of the angle in the second quadrant will be what? Negative. So which means we can use the fact that, okay, using the fact that if we have cos pi minus k, this will be equals to negative cos k. Okay, so which means this will be what? This is taken to be, this represents k according to this. So we are using this identity. So which means alpha will be equals to negative cos square bracket of inverse cos of beta plus inverse cos of gamma. Okay, now we need to expand this. Now, and to expand this, we can use the sum to product identity formula for cosine. So which means in this case, we're going to be using the sum to product formula for cosine, and this will be alpha equals to, now this will be open square bracket, this will be, now using the sum to product formula for cosine, let's say we have cos A plus B. Okay, this will be equals to cos A cos B minus sin A sin B, which means that inverse cos of beta is equals to A and inverse cos of gamma is equals to B. So if we apply that in this case, we have alpha to be equals to negative open square bracket, negative open square bracket cos inverse cos of beta, then cos inverse cos of gamma minus sine inverse cos of beta, okay? Then also sine, multiply by sine inverse cos of gamma, then close the square bracket. Okay, now, so alpha is equals to, so in this case, let's not forget that inverse cos of beta is A. Okay, then inverse cos of gamma is what? B. But in this case, we have inverse cos of beta. So that would be, this we cancel this. So we're going to have beta. Then also this we cancel this. That is when we multiply cos by 1 over cos. That will be 1. So this will be this will be gamma. Then minus. So in this case, this will be sine A, okay, multiply by sine B. Let's put it this way. Okay, now let's not forget that our goal is to what? Is to show that this expression is equals to 1. So what I will do in this case is I'm going to use that using the identity, using the identity sine A equals to square root of 1 minus cos²A. Okay, then also for sine B will be equals to square root of 1 minus cos²B. Okay, so we have that alpha will be equals to negative open square bracket beta multiplied by gamma, beta gamma minus, then in this case, this will be square root of, so 1 minus, now let's not forget that A is that's inverse cos of gamma. So which means that if we have cos²A, this will be cos A, which is inverse cos of beta, okay, raised to the power of 2. And that will give us beta raised to the power of 2. That will be beta squared. Okay. Then if we have cos²B, which is what we have here. So cos²B will be square bracket that's inverse, that's inverse cos of gamma. Okay, then raised to the power of 2 because B is equals to inverse cos of gamma. Okay, now, so this we cancel this, then we'll be left with 1 gamma. So gamma raised to the power of 2. So this will be equals to gamma squared. Okay, so in this case, so for cos²A, okay, cos²A is beta squared. So we have we have 1 square root of 1 minus cos²A to be square root of 1 minus beta squared multiplied by the square root of 1 minus gamma squared. Then we can close the square bracket. Now, I'm going to distribute the minus in this case. So this will be alpha equals to beta gamma plus the product of root 1 minus beta squared and 1 minus square root of 1 minus gamma squared. Okay, so now I'm going to isolate, okay, this will be negative. I'm going to move this to the left hand side so that this will be alpha plus beta gamma equals to the product of square root of 1 minus beta squared, okay, and square root of 1 minus gamma squared. Now, by squaring both sides, this will be alpha plus beta gamma, okay, raised to the power of 2 equals to, so if you square this, this will reduce to 1 minus beta squared multiplied by 1 minus gamma squared. Okay, so I can now expand the right hand side and the left hand side. If we expand the left hand side, this will be alpha squared plus 2 alpha beta gamma plus beta squared gamma squared. And this will be equals to 1 times 1. This is 1. 1 times minus gamma squared. This will be negative gamma squared minus beta squared multiplied by 1. This will be minus beta squared. Now minus beta squared multiplied by negative gamma squared. This will be plus beta squared, then gamma squared. Okay, so let's check if we have the same thing on both sides. Yes, these two are on both sides. So if I subtract this from both sides, okay, so this will be what? That will be equals to 0. So we'll be left with alpha squared plus 2 alpha beta gamma on the left hand side to be equals to 1 minus gamma squared, then minus beta squared. Now I'm going to carry everything, this one here, that's negative gamma squared minus beta squared. I'm going to carry it over to the left hand side so that this will be alpha squared plus gamma squared plus beta squared, then plus 2 alpha beta gamma is equals to 1. So this is how to show that alpha squared plus beta squared plus gamma squared plus 2 multiplied by the product of alpha beta gamma is equals to 1 using this equation. And with that, we've come to the end of this tutorial.